All right. So this would be called more calculating. All right, so we're going to do more calculations. All I'm going to do is example problems today. Let's call this example number 47. Let's see. What is the frequency of an EM wave? Whose wavelength is 625 nanometers. Which is something we can probably see with our eyes. That'd be like red, right?
You said that would be like red?
Yeah, 625 nanometers, that'd be red light.
Oh, I thought you said red.
No, red.
Maybe I'm hungry.
All right, so lambda is 625 nanometers. And remember C, we always have, that's 300 million meters per second. Would you guys prefer it if I use scientific notation, or would you prefer if I stick with
scientific notation? Because
okay. So 3 times 10 to the 8 meters per second. So that's 300 million.
That's always for C, or?
Yeah, C is always the same number. It's always 300 million meters per second. Now, if you look here, when we do our calculation to find frequency, these are not going to cancel because this is meters and this is nanometers. So today we got this extra step where we have to convert from nanometers to meters. All right, so before we do anything else, let's write that down. All right, so we got to convert 625 nanometers to meters. So what is the conversion? How many nanometers is how many meters? And you should have this somewhere in the front of your notebooks. It should say 1 nanometer equals 10 to the minus 9 meters. All right, from way back when we did conversions 30 years ago. All right, so when you do conversions, you put parentheses, you put a line through the middle. Nanometers is out here, that goes on the bottom. Meters is what we're trying to convert to, so we'll cancel with that meters. So that goes on top. 1 nanometer, 1 nanometer. 10 to the minus 9 meters, 10 to the minus 9 meters. And these, of course, are going to cancel, and then we're going to get this in meters. 625 times 10 to the minus 9. You actually don't need a calculator to do that. It's going to be 6.25 times 10 to the minus 7. No. And that's meters. All right, so we converted our wavelength to meters. Now we can do, now we can find frequency, which is the same thing we did yesterday. So if you remember yesterday, we said frequency equals C over lambda. So we're just going to plug in numbers here. So it's going to be 3 times 10 to the 8 meters per second divided by 6.25 times 10 to the minus 7 meters. And this is where this matters, right? Because we want the meters to go away. All right, so somebody go ahead and plug that in and tell me what we're going to get. And if you're plugging this into your calculator, remember that after you hit the divide button, you need to put a parenthesis, and then after you finish the denominator, put another parenthesis. Otherwise, your answer's going to come out wrong.
Wait, how do you get the minus 7 at the top?
625 multiplied by 10 to the minus 9 comes out that.
Oh, okay.
All right, who's got a calculator?
I have a mental calculator.
Okay, what's the answer?
It's broken. It has error.
It's going to be something times 10 to the 14. A little less than a half, or a little less than 5. So 4 and some change.
4.8.
4.8. is 10 to the 14, right?
Yeah.
And that's per second, because the meters all cancel. Questions? All right, so that's our frequency. That's pretty easy. Now I'm going to do a problem where I give you frequency, we're going to find lambda, and then I'm going to ask you to convert lambda into nanometers afterwards, because I like conversions and they're fun. Can I erase this, or are people still writing?
You can raise it.
I'll wait for a minute. All right, let's write the. I'll erase the problem and then I'll get the rest of it. Let me just erase it here. Okay, so let's call this example number 2. I don't know. We're going backwards today. What is the wavelength in nanometers of an electromagnetic wave whose frequency is, I gotta pick a big number, right? Otherwise we're gonna end up with some ridiculously small wavelength. Or no, ridiculously big wavelength. Let's do 4.5 times 10 to the 12 per second, or hertz. So that's like 4.5 trillion, right? 10 to 12 is trillion. All right, so let's list our givens again. So F is 4.5 times 10 to the 12 per second, or hertz. C is 3 times 10 to the 8 meters per second. And lambda is the thing we're looking for. Okay, so we know, well, we could do it, right? We want to solve for lambda, what we got to do? Divide both sides by f, right? So those go away. So lambda is c divided by f. No, we won't move past here. All right, so let's plug in numbers. It's going to be 3 times 10 to the 8 meters per second divided by 4.5 minus 10 to the 12 per second. They both have per second, so that cancels on the top and bottom. And whenever you plug this in, you're obviously going to get a bunch of 6s repeating, right? Because 3 over 4.5 is 2/3. That's like 0.66666. We just need to know what's the exponent going to be. What is it? Who's got an answer? You guys are killing me here. All right, 8 over 12, so this goes away, this becomes a 4, right? So it's 0.66666 times 10 to the negative 4, which would be 0.00000667. Yeah, that looks good. And that's going to be meters, right? It's seconds. Well, we're going to convert to nanometers, because we get the meters from the speed of light, and now we have to convert afterwards. All right, so we got our answer, but I asked you to give it to me in nanometers. So now, meters, nanometers, 1 nanometer, 1 nanometer, 10 to the minus 9 meters, 10 to the minus 9 meters. So it's going to be this number times 1 divided by 10 to the minus 9, which is really the same as multiplying by 10 to the minus 9. Nanometers, right? You really should take out your calculators while I'm doing this to make sure that you're plugging them in right and getting the same answers that I do. And to make sure I didn't make a mistake on that.
That's a 9, right? Or was that a 4?
This is a 9. 10 to the minus 9. Alright, questions on any of that?
No.
Alright. We could do other stuff, it's just nanometers is where visible light is. So that's why I kind of stuck with that today. Alright.